Alright, welcome. Today we'll be talking about volumes of pyramids and cones. Now, if you wonder why I drew a prism when we're talking about volumes of pyramids, I want you to take a look at the formula for the volume of a pyramid and then look at a prism. Prism is actually just this formula for volume. Okay. Now that you've had some time to take a look at it, here's what I want to point out. Here's some really cool facts about it. Okay, now volume of a pyramid and a cone are going to be 1/3 of their respective cylinder or prism volume totalities. And it's actually really kind of cool, and it's built from this principle. Okay, now if you remember, a prism is two parallel planes connected by lateral faces. Okay, and we're just making this right here. All right, and just for those of you guys tripping out, this is the bottom, and this is the top. Okay, all right. So, anyways, back to the actual shape. Now, a pyramid is actually the base, and instead of meeting up at a lateral at a focus point, it's going to actually meet at a point. Okay, so when I draw the pyramid, it's going to kind of look like this. So instead of meeting at the top parallel plane, I'm just going to have it be drawn like this. Oops. That got ugly fast. Let's go ahead and draw it again. Okay. And if you notice, it's almost like I kind of chiseled the pyramid out of this shape, and amazingly enough, when I chisel it, I'm going to chisel off 2/3 of the total volume of it, leaving us with 1/3. So that's why the volume of a pyramid is 1/3 times area of base times height. Now, I'm also going to explain too is that this formula is not derived from that chiseling. No one sat down and found the volume of a prism and then chiseled their way like Michelangelo towards a pyramid and said, oh, I just chiseled off exactly 2/3. This formula was actually arrived to by calculus. Thank you, calculus. And because they work so hard in calculus on this stuff, they wanted to point out to the fact that now you can deal and work with the fruits of their labors. Okay. All right. Now the same thing works for a cone with a cylinder. Okay. All right. So right now a cylinder is just right here. It's pi times radius squared times height, and that's just simply found by using calculus. But then it's also a 1/3 ratio. Well, that's because once again it is related to the fact that instead of meeting a parallel plane above that base, you are actually meeting at a point, and what you're doing is chiseling off once again and making a perfectly smooth cone a 1/3 of the actual volume. Okay, all right, that is it about volumes of pyramids and cones. Just remember that they are 1/3 of the volume of a prism and a cylinder, and you should be pretty set with understanding how the formulas work. Okay, well, actually not understanding, but rather being able to use them. Understanding how they work, you have to go through Calculus 3 to understand that and see where it comes from. Okay, all right, that's it for working with volumes of pyramids and cones. I'll talk to you later. Bye.